Okay, stat students. So this is unfortunately a remake of of Friday's lesson. I had mic issues because I didn't use my application. I didn't reset it, so it made my voice all choppy. So this is a redo of that. Hopefully it's better than the first one. Not that y'all would know the difference, but we're going to continue talking about random variables today. So let's go ahead and get going. Okay, so we talked about this idea of discrete random variables versus continuous random variables last time. Now, in this chapter, we really only care about discrete random variables. Remember that when I talked about continuous, that was chapter 2. So we're not going to be working with continuous random variables. We're really focused on discrete. So what I want to start off today's lesson with is I want to make a probability distribution of a random variable. This is going to be something you're going to have to be able to do, okay? So we're going to start by looking at this example. It says, let X be the outcome of rolling a fair six-sided die. So you can actually write this. This example it's in your problem set, so you can work it on there, or you can write it in your notes. But I would recommend that you work your problem set as much as possible. We've been doing a lot of examples in here, and we're going to do one more example after we do this one. So it says, let X be the outcome of rolling a fair six-sided die. That's what we want to do. So what we want to do to start this is we need to remember that a die is a discrete random variable. I have my die right here. It can only ever land on exact numbers. So when we're trying to create and we're looking at a problem like this, if it's not already given to us, we need to try to represent the sample space with the probability distribution. So let's go ahead and draw a line. We're going to start, you'll always do it like this. You're going to write X for the random variable, which is right here. It's the outcome of rolling a fair six-sided die. So we could get, we'll write out what those outcomes are. Then you have P of X, which is the probability of that individual outcome. So what is the first outcome that could happen when I roll my die? Well, here I rolled a 4, but we'll start from lowest to highest. We usually want to go in ascending order. Well, the lowest you could roll is a 1. And then you could go, and I'm actually going to type these in, so a 1 here. And it could go all the way to a 6. Now, this should not feel any different than what we were just doing last section or last unit. We were making these probability models. You had to be able to do it there. So this should feel very similar. So I will say that this is a simpler type of example that we'll be looking at for this unit, but at least it's a good starting point, and I think most everybody should be able to do this. So go ahead and write all this up, either on your problem or in your notes. Okay, so there's our possibilities. So that's what you have. Notice they're all numeric. They're all discrete, like there's gaps in between here. I can't get any decimals of rolls. Now we want the probability. So what's the probability of rolling a 1? Well, it's 1 out of 6, right? And then what's the probability of rolling a 2? Well, it's also 1 out of 6. And you'll notice that these are just going to repeat constantly here. So I'm just going to copy all of these into the next cells. So we'll move all that over, and congratulations, we've made our first probability distribution of a random variable, and it shouldn't feel any more difficult than what we did last section. Okay, all right, so now we're ready to answer questions, and we have this question up here. It wants to know what is the probability of getting a 2 to a 5. So what this actually wants to know, because we have the equal to symbol here, less than or greater than or equal to, and this is less than 5. It wants to know including 2 or greater, but less than 5. So this is 2, 3, or 4 is what this is actually asking. So I want these 3 outcomes here, a 2, a 3, or a 4. So I'm just going to add those up, and what that gets me is 3 out of 6, which is equal to 1/2. So that is a pretty straightforward example, but that's the type of questions that we'll be answering in here. Okay, so that's the random variables. Now we're going to move this into a new context. I've talked about how this chapter and in last chapter with probability, it really is me trying to explain why gambling is bad and you should not waste your money on it. It seems like gambling has really gotten big lately on all these sports and stuff, but it's kind of difficult to make probability models for like sports, right? This is a very simple probability model, but casinos and places that design these games or these like to where you can win money, they use this. This is what they have to do. They're statisticians, they're probability experts. When they're developing the games or going through the games, they have to know these numbers, this math here, to be successful at that. So we're going to watch a video to talk about casinos a little bit. And in this video, this show is called United Stats of America. Let me pull up this thing. So this is what the show looks like. And I bought this whole season, which it only has one season. It's 2012. It's these two twin brothers that ask all these questions. They talk about how Americans feel about, death and living, like just different things. But we're watching this one about money talks. And here they're trying to strike it rich and talk about how the average salaries in America. But these two brothers say, okay, we're going to get rich. One of them goes and mines for gold. The other one goes to a casino to try to win money there, okay? So that's the scenes we're going to be watching, is just the ones in the casino. So let's go ahead and get that started. Let me minimize get rid of my camera. Here we go.
While Jason gambles on gold making him rich, I'm going to wager on betting.
Watch out, because I'm lucky. You too. I'm going to need some new drapes. Daddy's going to get them for you. God, I lost everything! Kidding, I didn't lose anything. I didn't even play anything yet. That's how my mind works. Reverse psychology.
First stop, the penny slots, the most popular game on the casino floor.
Penny for your thoughts? How about a penny for my jackpot? Pal. This is it. I'm gonna get rich right here. What? I think this thing is defective. I'm starting to hate this music, too.
Last year, close to 68 million Americans tried to beat the house at one of the nation's casinos.
Come on!
But as the saying goes, you can't beat the house.
Kidding me?
And casinos are really cleaning up, to the tune of $35 billion in annual gaming revenue.
Why am I sweating? I should not be sweating this much. And yes, boom, 30 cents. I could have made a phone call in 1984 with that. Thank you very much. Stupid idiot! Even though it was 9. Ah!
Looks like you're having some trouble there. Looks like you're not having fun. Can I offer you
Sorry, I hate gambling when I lose.
Can I help you out a little bit? Offer you a few gambling pointers?
Who are you, first of all?
My name's Mike Cahill. I'm a international casino expert.
Are you my gambling guardian angel?
I am.
I never thought it would be you, but come on over and help me out.
Hopefully, Mike can help me figure out how to make a ton in one night. And more importantly, destroy Jason.
I feel like I'm not winning like I want to be winning. I'm winning sometimes, but I'm not winning.
And this is a penny slot machine.
Okay.
Typically, the lower denomination slot machines pay out less than the higher denomination machines. So essentially, you pick the lowest payout machine available in the casino.
On average, for every dollar wagered on penny slots, the house makes 18 cents.
I gotta spend more if I want to win more.
You gotta risk more. You gotta get some more dollars out there flowing. The other part about it is, compared to other games, this is relatively mindless.
It's mindless like a Larry King interview. Just completely turn your mind off. You're not gonna learn anything.
And much like Raymond in Rain Man, we're good at math. And I'm catching on that the odds might be better elsewhere in the casino. Let's try blackjack. Yeah, blackjack. Definitely blackjack.
I got a hundy. Let's see what we can do with this.
The rules of blackjack are simple. You want your cards to total 21, or as close to that as possible without going over.
All right, so tell me some of the advantages to playing blackjack odds-wise versus slots.
If you're good and you're just slightly lucky, it's really advantageous to the player. But in the end of the day, the casino still has the advantage.
Right.
Place your bets.
The more skill a game requires, the lower the house advantage. In blackjack, the advantage may be less than 1%. That means for every dollar wagered, the house makes less than a penny.
Yes.
I will take those odds, thank you.
Knuckle it up.
Finally.
Why are you happy that we won?
I want you to have a good time, and when you win, I win.
Why is that?
Casinos want people to win. First of all, it creates the environment. It creates the action.
Yes, the excitement.
Second of all, most people win and keep playing.
Right.
They win, they lose, till eventually their money is gone.
I am gonna double down.
Oh, we're both
here
doubling
we go.
down.
It hit me. Hit me, but not too hard. Here we go. Thank you. I'm gonna take a card. Oh man, God, killed me. I'm losing. Look at my stack. It's no longer a stack.
Will Randy's
Okay,
cards?
I'm gonna fast forward it. Where do I go to? Let's see. It's him in the gold mine. Okay, here we go.
For 20, 50 bucks.
If I'm gonna make more money than Jason, I need to take bigger risks. It's time to bet on roulette. I know my chances are gonna be better here.
All right, tell me about the odds here.
If you pick one number, if you have a lucky number,
Right.
you're gonna get paid 35 to 1.
That's what we're talking about
Some
here.
serious money.
So $25, that's $875.
$875.
This is roulette. This is what I came to do. I came to get rich. I'll tell you what I'm gonna do. I'm gonna put it on Lucky 13.
All right, make my man happy. I owe it to him. Come on. Okay, now try and spot the number on the wheel. Put your vision on it.
Why are there even chairs here? Who sits down at roulette? 5.
Oh,
Red hot. Are you kidding me?
oh. All right, there goes all the money. It's the statistics. It's math. The casino always wins in the end.
All right, so that is that's the scenes that I wanted to talk about, and the next idea that we're going to be discussing is something called expected value. So in the scene there, in the clip, you see those games. You have roulette, you have blackjack, the slot machines, and when they make those games, those are discrete random variables. There are specific outcomes that can occur for the player, and as far as money that they're earning, and they do the math on how much they're going to make, and it's interesting how for the slot machine, they said every dollar that a guest spends, the casino is taking on average 18 cents. So really, as a player, you expect to lose 18 cents every time that you play. That's terrible, right? Like, is that fun? Not really. Okay, it's mindless. That's why, especially those games, you don't want to play those, okay? Now, if you are going to go to a casino one day, and he said, if you are skilled and have a little bit of luck, the blackjack is the most advantageous. That would be the recommendation. But again, you need to be skilled. So don't just go in there and be like, oh, I heard that blackjack's what I need to play. You don't want to just go in thinking that. Okay, that's you're going to lose your money probably. So less than 1 cent per dollar spent. So you're expecting to lose less than a penny per time you play on average, and that's, again, if you're good. If you're bad, that number will be fluid, right? But that's what the casino expects on average from their distribution, their math. Now, that would be a much more complicated random variable table for really all of those than just this. Okay, this is a very simple way to show a discrete random variable. So we're going to try to calculate some of those numbers on our own. How much do you expect to make when you play a particular game? And we're going to start simple again, and then we're going to do some real-world examples. But let's go ahead and go to number 13 and 14 in our problem sets here. So we're going to work these. Let me pull up a new drawing here. Okay, it says, in a particular game, a fair die is tossed. If the number of spots showing is either 4 or 5, you win $1. If the number of spots showing is a 6, you win $4. And if the number of spots showing is a 1, 2, or 3, you win nothing. Let X be the amount that you win. All right, so again, we need to, and whenever you're reading a question like this, you want to create the probability model, or that distribution. So we have X, and we have P of X. And by the way, you will need your Inspire, so if you don't already have it up, go ahead and grab that right now. So go ahead and have that ready. I'm gonna go ahead and have a blank spreadsheet prepared here. We are gonna need that to help us with one of these problems. So this time for X, we're not actually interested in the die rolls, okay? Because a casino is more interested in how much they're gonna be making. All right, they want to know dollar amounts. And for us, we are going to want to know dollar amounts. So we're going to start with the lowest. What's the least amount that you could make playing this game? Well, here it is. It says you can win nothing. So that is $0. Okay? So that's how much you would earn. Next, you have $1 that you could get. And then lastly, you could get $4. Okay, so now what we want to do is, these are the outcomes, and you notice something about this game, you're not paying to play. So really, you have nothing to lose here. You're going to probably win some money. But let's go ahead and write out the probabilities of getting all of these different dollar amounts. So you are going to win nothing if there's a 1, 2, or 3. So that's 3 out of 6. Now I know you'd want to put 1/2 here, but we want to try to keep a common denominator here of the outcomes. So $1, you get a 4 or 5, so that's 2 out of 6. And then lastly, $4, you have a 1 out of 6 chances. All right, so we have that. Now, this is our probability model, and here it says, which of the following is the expected value of X? Okay, what do we expect to happen? That's what we want to know. So in order for us to do this, I'm going to start by making a graph. So I want to draw this distribution. So I want everybody over here to the right, and if you're doing this in your notes, that's fine. I want you to make a distribution over here. So I'm going to put 0 here. Okay, that's 0. I'll put it over here. There we go. Then I'm going to put little tick marks, and this is going to represent the other values that are possible. So this is our x-axis here. So I'm going to put, this is 1. I guess we'll put dollar signs in here as well. $1. So this is in dollars, and we're going to put 4 here. I'm not going to put really the other numbers. We know what those are. So there we go. So $4, and I guess I'll make this $0. All right, so this is our random variable X on the bottom. Now on the y-axis, we want to put our probabilities. So I'm gonna go, we'll go up 1, 2. We only need 3 here because this is gonna be 1 out of 6, 2 out of 6. No, sorry, 3 out of 6 at the top. And then 2 out of 6 in the center. Sorry, I should have wrote those in order, but it's fine. So there's our different values. Now what we're going to do is we're going to make a histogram. Also, I need to label this side. This is probability of that event. So we're going to make a histogram. So the first value, getting $0, that will be 3 out of 6. All right, next we have getting $1. We're going to draw this histogram. That is 2 out of 6. And then finally getting $4. I need one more tick. I wrote 4 at the wrong spot. 4 is actually here. $4 is going to be 1/6. Okay, so now what we're going to do is we're going to describe this with socks like we did in our very first chapter. So what is the shape of this? Well, hopefully you're seeing it is a nice, or a pretty severe skewed right distribution. That means it's very unlikely you're going to get a large amount of money. Let me move my camera. Oh no. Move my camera over. So this is skewed to the right. We're just thinking about these. I'm not writing anything. I'm just thinking. We're not really worried about outliers right now. Now what we actually want in this case is to find the center. Okay, so where is the center point of this? If I had to find that balancing point, well, it sort of looks like this might be that balancing point right here. So we might say about 1. And remember, sometimes these can be decimals, but this is discrete. So, you know, you'd be thinking, oh, it might be, you know, a value that I expect to get. So it looks like $1 is sort of the center. Next, spread. Well, that is standard deviation, which we're going to get to, but it's we'll talk about that in a second. But we want to find this expected value. That's what we want to do. So in your notes, I want you to write the word expected value. Keep messing up my camera here, or my screen. Expected value, and we're going to be looking at a definition. And so in your notes, I need you to write this mean expected value. And here's our definition. It says of x, multiply each possible value by its probability, then add all the products. We don't actually need to highlight. You don't have to write this. So this is the expected value of x. You should write this for your title of your definition or the term. Expected value of x. Multiply each possible value by its probability, then add all the products. So this is actually on your formula sheet. For dual credit, you'll find it on page 2. It's near the very bottom underneath all the probability rules. It's the first one. And then AP, I can't remember what page it's on for y'all's, but you have this formula in it. So let's go ahead and do this. I'll pause to let you write it, but then we're going to do it. All right, so you should have written it by now. Let's go ahead and answer this question. So to find the expected value, we need to multiply each value by its probability. So that's what this blue is representing. Once we multiply them all together, we're going to add them. So it's going to be 0 times 3 out of 6 plus 1 times 2 out of 6 plus 4 times 1 out of 6. So that's what we need to do. Okay? And what you should get for this, if you type that in, you can type that in your calculator, but you will get 1 for this. $1. So you're expected when you play this game to get $1 every time you play. Okay? That is the expected amount, and that's how you're going to find that. Now you can do it a different way, and we're about to do that because when we talk about standard deviation here, because that's what number 14 wants, find the which of the following is the standard deviation of this. We can't just look at a graph and tell what that is. Okay, we can't really tell. We know where the mean is, and remember, standard deviation is how spread apart from the mean the values are. But it's not easy to just look at. So remember that was one that had a very complicated formula, and it still sort of holds the same here. This is actually for the variance. The standard deviation would be square root of that. So we're not really going to be using this formula. We're actually going to have our inspires do this for us. Okay, and the same goes for AP. You actually have the standard deviation formula on your sheet, and it is as complicated as this one looks on here. So we're going to rely on the calculator to do that for us. So let's go ahead and pull up the calculator. Go ahead and open your spreadsheet up for me, please. And we're going to go ahead and start typing in the distribution. So what you want to do is you want to type in X for your first list and PX for your second. And we're going to take the table over here and we're going to put it inside of our calculator. And if you need to rewind any of the steps here, you can do that. I'm going to make sure you're able to rewind. So I'm going to put 0, 1, and 4 inside of my cells. And that's just coming straight from this table here that we have. So 0, 1, 4. Now we want to put in the probabilities. So the probabilities, we're going to type them as fractions, and the calculator will automatically simplify them for us. So the probability of getting 0 is 3/6. The probability of getting 1 is 2/6. And the probability of getting 4 is 1/6. So there's our values. Okay. Now what we want to do is we are ready to find our standard deviation. So let's talk about how we want to do this. We're going to go over to a blank cell over here. And we need to go back to something we did back in chapter 1 and the second unit, which is we're going to find the 411. So everybody needs to press menu 411. Okay, and you should see this. Now hit OK, and let's pause here for a second. What we used to do only was just type in the X list and hit enter, but we got to change that this time. Go ahead and hit to the right on your directional pad, right here, the little touch pad. twice to get the drop down list and go down to X. That's going to be the X list. That should make sense. Next, we want to go down to this frequency list. Usually we keep it at 1, but we're changing it this time to, that's going to be our probability. So it's telling you for the X list, here's the frequencies that they happen within this random variable distribution, okay? So we're going to hit OK because we have everything else we need. So we'll go all the way down, hit OK, and it spits out what we want. Now you'll notice in the first column, look at that, or this first cell, X bar, which is mean, right? That's 1. And you'll notice that's exactly what we calculated for number 13 here. So this is a faster way to find the mean. Okay, this is going to work out for you a lot quicker if depending on the type of distribution. All right, so let's go down, and you'll notice that S sub X here is undefined, and so that was usually what our standard deviation was when we were working these problems. But we are now going to be using sigma of X for these random variables, and it's only for these random variables that we're using this. So make sure that you remember that. Normally S sub X is going to be our sample standard deviation, but since we have the entire distribution here, or the whole sample space, this is a population standard deviation. That's what sigma of X is. It's population standard deviation. So 1.41421 is our standard deviation. We look over here, C is the correct answer on this one. So that's sort of our lesson today. What I wanted to talk about is this expected value and standard deviation for a probability distribution, or for a random variable. And now you should be able to work, let's go back to our problem set. You do the same thing with number 15 and 16. The lucky part is that they've already made the probability model for you. Okay, and you can get the expected value or the mean. 17 is pretty difficult. But this is an idea. You're playing scratch off cards, which we'll do our example of like lottery stuff soon. Then we have expected value. You can answer all the way through 21. Now 21 is one that I'll do as an example probably in the next lesson, because we're not done with expected value and mean. But you can go ahead and start looking all the way through 21. So we've gotten through a lot of this chapter already just in one lesson. So I'm going to go ahead and end it here. If you have any questions, make sure you reach out to me.